everyone. So I'm hoping that you have already had a Zoom call with me and we've chatted through the fact that we're going to start revising. I was thinking of starting revising C1 and then I thought C1 is fairly easy and you revised it for your mock. Our one lesson of revision that we managed to get in was on C1 and it just seemed pointless to go back over it, really. You know, you either know it or you don't. So rather than me spending time on it, I thought C2 is a little bit more tricky. It's actually got stuff you can apply in it. So I thought that'd be more useful for you, basically. So I thought we'd start. I won't do the whole of C2 in one lesson. That'd be far too much. I'm actually just doing a little bit of C2.1 today, which is all about formula and masses, because I thought that's really useful. So even if, you know, whatever happens in terms of these assessments, who knows, but at least this would be useful for you whatever happens in chemistry. So yes, here we go. So you are more than welcome to take notes on this. You don't have to. You can just listen to me chatter on if you want. But if you do want to take notes, feel free to pause the video at any point. So the first thing I thought I'd talk about was the relative atomic mass, which is shown by a capital A and a small r. Now, just a quick note, the r is normally subscript, as in, I'm not going to be able to draw anything here, like that, like a little r down. So not like this, A with a subscript r. All of these. So yes, relative atomic mass, AR, which is the mass effectively of one atom. Now the official definition is it is the mass of an atom of an element compared to an atom of carbon-12. They love carbon-12. It is shown by the mass number of an element in the periodic table. So, for example, oxygen in your periodic table is 8 and 16.0. The larger one is the mass number, and that tells you the relative atomic mass of oxygen. So the relative atomic mass of oxygen is 16.0. So again, let's go. Okay, next bit, chemical formula. So you would see these all the time, but I just want to make sure you're happy about how to interpret them. They tell us how many atoms of each element there are in a molecule. So I've put some examples here. H2O has 2 hydrogens and 1 oxygen. I know that because that little 2 there is linked to the hydrogen and it's telling me that there are 2 hydrogens there. Oxygen does not have a number attached to it, so there's only 1 of it. Remember, if I wanted to double all of those, I could put a big 2 at the front, and that would double hydrogen and double oxygen. It would double everything there. Just trying to get rid of it. I just scribbled a bit more. Okay, next one, Al2SO4. So we've got 2 aluminiums, 1 sulfur, because you can hopefully see there's no number attached to it, and 4 oxygens. Hopefully this is fairly straightforward, you're remembering everything. Now let's do the next one. Al2, again, 2 aluminiums, but this time, can you see there's an extra set of brackets there? And that there's a little 3. That 3 corresponds to everything in the bracket. So now we've got 3 sulfur and 12 oxygen. And I know that there's 12 oxygen because there was originally 4, and now I've got 3 lots of 4. So there's 12 oxygen. So again, that bracket, everything in the bracket is times by 3, but not the stuff outside. Okay, relative formula mass. The mass of a molecule, so remember a molecule is lots of different atoms joined together, compared to the atom of carbon-12. And you can find it by adding together all the AR, remember that's atomic masses, of all the atoms in a formula. So again, I've done some examples here. H2O. I went to my periodic table and I looked up the relative atomic masses of hydrogen and oxygen. So to work out the relative formula mass, which is MR, that's M and a little r again, so not MR, but M with a subscript R, I'm just going to add them together. Now I'm not just going to do hydrogen plus oxygen. There are 2 hydrogen atoms there, so I need to do 2 times 1, because that's the hydrogen, plus an oxygen, which gives me a total relative formula mass of 18. So because there's 2 hydrogen, that's why I've done that. Now let's do a slightly more complicated one. Probably going to have to get my calculator out. I'm good at mental maths, but I'm not that good. So magnesium. So that's 1 magnesium there, so 24 plus 3. And then have a look, you've got those brackets again. So I've got 2 oxygens there. So 16 times 2, plus, and then I've got 2 hydrogens. So there you go. Right, so we'll add that all together. So that's 24.3 plus 32 plus 2. I should probably be able to do that in my head. 58.3. Should probably check it. 2 plus 2 plus 24.3. Oh, didn't turn my calculator on. Second time lucky. 58.3. I should trust myself. There you go. Right, now let's go on to empirical formula. I know these all sound very similar. The empirical formula, I'm going to say the simplest whole number ratio, not who number ratio. Yeah, right. Okay, so the simplest whole number ratio of the atoms of each element in a compound. Some formula are already in this form and can't be simplified. So what you're basically doing, you're looking at a chemical formula and you're saying, oh, we can make it more simple if we just cut it down by a factor of 2 or a factor of 3. So I've given some examples. Some formula, by the way, can't be simplified. They're already simplified enough. So H2O, you can't make it any more simple. You have to have 2 hydrogen, you have to have an oxygen. You can't cut that down. But this one, C6H15, think, okay, fair enough. But that is quite large numbers. Can I simplify that equation to say for every 1 carbon, for example, or 2 carbon, this is how many hydrogen you need? Now I look at both of these numbers and I think, okay, what is their lowest common denominator, or the highest common denominator? What can I divide both of them by, basically? And hopefully you're looking at that and thinking, oh, you can divide both of those by 3. So let's do that. Let's divide both sides by 3. So then I'd end up with C2H5. Now have another look at it, because it might be that you do it once and then think, oh, I could probably get that down again. Is there any number that goes into 2 and 5? No, there isn't. So this is the empirical formula. God, can't spell formula. It is the whole number ratio of atoms. So I'm saying for every 2 carbon atoms, there has to be 5 hydrogens. Okay. So you've got the normal chemical formula here, and then the empirical formula over there. Now let's do another one. C4H8O2. So look at all those numbers. Is there anything they can all be divided by? 2, I'd say. So let's divide it all by 2. So you end up with C2H4O. And again, is there any number we can divide that by? See if we can simplify it further. No, there isn't. So that is your empirical formula. So spelled empirical right this time. Right, our final bit that we're looking at is using masses in balanced equations. So the total mass on the left-hand side of an equation should be the same as the total mass on the right-hand side. And you can use this fact to work out any missing values. So I've given an example here. So you've got carbon plus O2 goes to CO2. So what I can do is say, right, the mass of carbon, the atomic mass is 12. I got that from the periodic table. Then oxygen is 16, but there's 2 of them. So I've had to do 16 times 2. And then on the right-hand side, carbon plus 2 oxygen, 44. So let's just check it. So we've got 12 plus 32 goes to 44. 44 goes to 44. Look, it balances. Lovely jubbly. And this is the next example here underneath. This is me using it to work out missing values. Now, I know if you just look at the equation above, you'll be like, oh my God, I know the answer. But you might not have the equation above. So this is a way of working it out. So what I'm going to start with is the right-hand side. I've got 2 lots of carbon, which is 12, plus 2 times 16. Okay, so that big 2 is the same as that, like 2 lots of everything in there. So 2 times 12 plus 32, 2 times 44, which is 88. So on the right-hand side, it's 88. Now we need to work out the left, and that will hopefully tell us what it is. So we've got question mark times 12 plus 2 times 2 times 16. Now you might be thinking, where's the 2 times 2 come from? You've got 2 here, that's that one, and then 2 there. So that's why I've got the 2 times 2. So question mark times 12 plus 4 times 16. Question mark times 12 plus 4 times 16, 64. So Currently, I have question mark times 12 plus 64. Now, in maths, I want to get that question mark on its own. How can you get a question mark on its own? You have to start taking things away and dividing by things. So the first thing I'm going to do is I'm going to take 64 away from both sides. So question mark times 12 goes to 88 times 60, take 64 is 24. So I minus 64 from both sides, like, to try and get it out. Then how do I get rid of a times by 12? I do the opposite, I divide by 12. So question mark is 24 divided by 12, which gives me 2. So after all of that, I could replace that question mark with 2 to show I know how many there is, and I've done that by working out the masses of both sides. Right, there are some questions for you to have a go at. Please let me know if you're not sure of anything, and I'll see you soon. Bye!